Did you know Digital Insurance has a free newsletter that features important industry coverage and analysis? It's called The Morning Briefing, and you can get it delivered to your inbox every weekday. Join a community of insurance leaders committed to advancing the industry and their careers, and start your day with can't-miss coverage of the stories that matter most. Sign up for free today at www.dig-in.com. Hello, and welcome to this edition of the DIGIN Podcast. I'm your host, Patti Harman, Editor-in-Chief of Digital Insurance. The National Oceanic and Atmospheric Administration predicts an above-average hurricane season, which could mean 17 to 25 named storms, with 8 to 13 of them expected to become hurricanes with wind speeds of 74 miles per hour or more. And the forecasters also anticipate that 4 to 7 of these storms could become major hurricanes. And we're talking like a category 3, 4, or 5 with wind speeds in excess of 111 miles per hour. But it only takes one storm making landfill in a heavily populated area to cause millions in damages. So I've had some experience with hurricanes in Florida, South Carolina, Maryland, and New York. And I've covered damage resulting from some really ferocious storms. And I can almost guarantee that if I go on vacation toward the end of the summer, there will be at least one hurricane that makes landfall somewhere along the East Coast. I think I have like a 95% average for some reason. It's really kind of funny. But here to talk about weather, hurricanes, forecasting, and the technology available is someone far more qualified to discuss this topic than I am. Howard Altschule is the CEO and Certified Consulting Meteorologist for Forensic Weather Consultants, one of the largest weather expert firms in the country. He works with carriers to confirm past weather data to verify hailstorms, high winds, storm surges, and more. So thank you so much for joining us today, Howard.
Patti, thank you. It's a pleasure to be here.
So let's start with an easy question, which is, why did you decide to become a meteorologist, and what did that involve?
You know, I've wanted to be a meteorologist and have had this fascination with weather since as long as I can remember. So, I mean, you're talking, 7, 8 years old, 9 years old, 10 years old. I often tell people, like right now, I'm looking at autographed pictures of Al Roker and Willard Scott from probably 20 years ago. I was a weather watcher for Al Roker when he had hair. And it just gives you an idea of how long that was ago. Back in the 1980s, I was a weather watcher. I was the guy that had that weather station in his backyard, measuring the rainfall amounts and the temperature, calling the TV station and talking to Al or Nick Gregory or WOR radio in New York City, and then listening for my name on the radio after that. I just had my nose peeled to the window, my eyes outside anytime snow would fall, anytime there was a blizzard. And certainly thunderstorms were my big passion and still are probably my favorite thing. So, I'd be up at all hours of the night watching thunderstorms, giving forecasts to the point where, I earned the nickname Hurricane Howie back in junior high school, and then in high school did the weather on the local cable TV station. So I think that's where this was all born from. And, I ended up following my passion and going to college at the State University of New York at Albany, which is in upstate New York. And that's only maybe like 5 miles down the road from where our corporate headquarters is right now for forensic weather consultants. And I obtained my degree, a Bachelor of Science degree in meteorology or atmospheric science back in 1995. So quite a long time ago, and I've been in the business since then and had many different weather jobs, or not many, just a few, some pretty glamorous, where I was forecaster for the Mets and the Yankees and, movie producers and things like that. And I also had about 8 years on TV at NBC as an on-camera meteorologist. So I mean, the passion has been there up until today, and it continues to be there, both professionally and also as a hobby. And it always will be a hobby, no matter what, even when the day I retire.
So how did all of that training help you with the weather and the storm tracking that you're doing now?
Well, SUNY Albany is one of the best universities in the country for meteorology. And even back then, it was one of the top. So we had excellent professors and excellent classes and coursework. And, one of my first jobs out of college was at a company down in southeastern New York, where I did a lot of forecasting, as I mentioned. But they also said they, needed some help in the forensic division. And this was the mid 1990s. I didn't know anything about forensics back then, but, they said that they would train me. And I'm like, okay, I'll help out, brand new out of college, first year. So I started learning about, forensics there and started learning about what they did. And I was, trained kind of minimally back then about what to do. After that, I left that company, went to work for the TV station. And, I got, the TV station back then as a number 4 guy on the totem pole didn't pay a very good salary. And I was getting up at 3:30 in the morning every day to go get ready for the morning shows. And I was like, it's got to be something better. I need to supplement my income. So I started my business, Forensic Weather Consultants, in 1999, 25 years ago this September. And it started out working on one case every 4 months, where I literally opened up the yellow pages, typed up a letter to all the attorneys in Albany, got one case every 4 months, reinvested in mailings and, advertising. And now we're probably about 700 or 800 cases a year that we're working on here with my team of 8 other forensic full-time meteorologists.
Wow, that is just a fascinating background. I didn't realize all of that about your company. Thank you so much for sharing that.
My pleasure.
How has the technology that you use to track weather changed over the years? And I guess what everybody would like to know is, has it increased the degree of accuracy for predictions at this point?
Yeah, no, it definitely has. When I was talking about doing the weather on TV back in high school and other meteorologists or weather people like Willard Scott back in the day, we used to put magnet like cloud figures and thumbtack raindrops on a cork board showing where the weather is going to be. So over the decades, technology has really advanced. And it continues to just explode with new technology and advancements with artificial intelligence and machine learning and predictive modeling. But, one of the biggest tools we have that goes toward severe weather tracking and not only forecast, but also going back and looking at hail claims and stuff like that, but also for hurricanes, is Doppler radar. There's Doppler radar imagery that ingests all the information. We have satellite imagery that we never had anything like before. So satellite images go into the computer models, especially ones that forecast hurricanes. There's weather sensors and weather data on airplanes, commercial aircraft now. So like Southwest Airlines or United, some of those or many of those have have weather sensors that transmit data to NOAA. We have weather balloons that go off. You have UAV drones that are being flown. You have sensors in the Atlantic Ocean and the oceans that are just kind of floating there as buoys. And all of that data, there's weather sensors like in parking meters in some places and on electric vehicles. So all of that data goes into computer models and new, high resolution computer models that people are generating. And that goes toward forecasts, hurricane forecasts, primarily the most important, because that could have the biggest devastation and the most significant impact on life and property over a very large scale. So those are just some examples of how technology has really, really improved over the past, not only several decades, but especially over the past like 3 or 4 years.
Very true. We've been at Digital Insurance, we covered that intersection between technology and insurance, and it's just been absolutely mind-boggling to me how much technology has changed so many different facets of the industry. So I mentioned earlier that NOAA is predicting an above-average Atlantic hurricane season. What kinds of weather developments do you and other meteorologists track then to see where and when these storms might originate?
Yeah, so using climatology and past weather data from the past 15, 20, 25 years, we can track things like ocean temperatures or El Nino or La Nina, which is a change in the global circulation patterns. And, in the Pacific Ocean, one means above normal water temperatures. The other, when that happens, is above normal or below normal water temperatures. And depending on which one occurs, changes where thunderstorms develop, where the winds are stronger, and basically changes the whole global jet stream and circulation pattern. So when you're in a La Nina pattern, that has a tendency to mean a much more active hurricane season for the Atlantic, the Caribbean, and the Gulf of Mexico. So all of that technology and being able to track the water temperatures and now these computer models and using artificial intelligence, going back year by year by year, saying, okay, when the water temperature was the way it is now in 2024, what happened in that same type of scenario? And we can gauge how busy or active we expect the hurricane season to be based on that, or vice versa. Now, for this year, all of the correlations are saying that we're going to be in a La Nina pattern, which usually almost always means above normal or well above normal hurricane or tropical storm activity. But what we have now going this year is near record ocean temperatures in the Atlantic and the Gulf of Mexico. So now when you have an atmosphere that favors development of tropical storms or hurricanes, combined with way above normal water temperatures, ocean temperatures, which is the fuel for tropical cyclones, all the indications are that, we're going to have a lot more tropical storms and hurricanes than usual, and they could be quite fierce. And just the way history has shown the steering patterns suggests a higher threat of maybe tropical cyclone or a hurricane hitting the east coast of the U.S. or Florida or the Gulf Coast or kind of the Caribbean islands.
Wow. Yeah, just even with the storms that hit Florida a couple of weeks ago, it was amazing how much rain came down in just such a short period of time. How are you using technology to monitor the weather before and after an event, like a hailstorm or a hurricane or a sleet or ice event? Because I know you can confirm specific types of weather events, but how do you actually track and confirm that they either did or did not occur?
Yeah. So that is why we are so busy at Forensic Weather Consultants. As I mentioned, we're like 10 times busier than we've ever been, Patty. And I think that's because of the outreach I've been doing, speaking at conferences, going to a lot of insurance carrier headquarters or regional offices, or doing webinars about forensic meteorology. And they're seeing the value in what we do, right? They're seeing, wow, we only thought you could look at, the airport wind speed or, an automated report, which has problems quite often. We didn't know that this type of data was available. So we, when I give these presentations, and I was, in New York City just, yesterday, giving one of these, I showed all these different types of weather records, all these different types of stations that most, claims adjusters or attorneys or engineers aren't even aware of. And I showed how we use them. Like Doppler radar is one of the biggest things. What we do is we plot a specific property or loss location right on the radar images. Those are processed every 1 to 5 minutes, and we can track precipitation. We can see if it rained at the 7-Eleven, 10 miles away from the airport, but maybe not at the airport itself. We can see if it hailed, at your house, but maybe not, a mile away. And I think history has been such that, a lot of adjusters and engineers, they only use, they can only use kind of like what's being reported by NOAA or what the winds were at the airport. And, quite frankly, the weather, as you know, changes dramatically over short distances. So we're able to answer those questions. Now, technology with Doppler radar has really advanced in the past 10 years or so. We have things called like dual pole radar products, which not only does it show you what the weather's like and where it's raining, like during the weather on the TV news at night, but we can now see whether there's hail in the thunderstorm, or whether it's just rain, or whether it's a mix, or whether it looks like it could be really large. And we corroborate that with, storm reports on the ground and other sources of information. So radar can detect tornado debris. So we can actually confirm sometimes if there's a tornado occurring by the radar picking up debris, 15,000 feet in the air. It's fascinating stuff.
Wow, it really is. Yeah, I'm based in Maryland, and we had, I think, 10 tornadoes come across the state like a couple of weeks ago. And it was just really interesting to kind of watch the weather forecasters and talking about this is how we confirm that it hit in these areas and all of that sort of thing. So that's just really, it's just really so interesting. So we've seen the frequency and the severity of storm events kind of grow over the years, like the 100-year, we hear like the 1,000-year flood events. What do insurers need to consider when they're writing coverage in these areas? And I'm wondering, can you really assume that a 100-year flood really won't take place for another 100 years? I'm thinking locally here in Ellicott City, I think within a 2 or 3 year span, they had 200-year flood events. So as a carrier, how do they even begin to anticipate what kind of coverage or how severe some of these events could be?
I think I worked on one of those flood claims in Ellicott City, actually, because I remember when they occurred, maybe like 10 years ago or something like that.
Yep.
Yes, it's a small world, right? It's interesting because the weather is definitely changing. There can be a lot of people arguing that it's, global warming or climate change. And it is to some extent, there's no doubt about that. And I think we all agree the weather is changing and getting worse. And I think, there's new climate models, there's new updated information and better sources of data that's being compiled so that insurers can see what kind of risk there is. For instance, we have an automated, hail swath program that pretty much every hour tells us what the Doppler radar was showing hail size to be anywhere in the country and Canada. So you can go back and use that data every day. And we have, probably 8-9 years of data every single day. And you can see what areas have had hail and what the radar's, shown there to be hail. So they could, base their risk on, all right, what areas had minimal hail, what areas might have seen more hail than they've ever had before, or rainfall, and in terms of those 100-year storms, because, it's warming up, that helps, with evaporation and more moisture in the atmosphere and bigger storms, more powerful storms. So those 100-year storms are happening more frequently. So I think using the more recent data, whether, maybe not a 20-year historical data set, but, maybe that in conjunction with maybe a 5 or 10-year historical data set might capture some of the more frequent recurrence intervals of that. So I think there's a lot of information out there. Carriers, I think, really need to consult with, forensic meteorologists and climate modelers to understand, all right, what data is available? How can we model this and account for the changing risk?
Really helps them in terms of their underwriting accuracy then and kind of figuring out what could be. So that's great. Thank you. So what factors can affect the trajectory of a storm? I know we're always watching when a storm's coming in and you hear the forecast, and then all of a sudden it'll go out to sea or further inland unexpectedly. What kinds of factors can affect a storm then?
Yeah. One of the biggest problems, Patty, is that there's very limited data in the oceans to take measurements, right? To take measurements of temperatures or air pressure. That's the information that gets ingested into the NOAA computer models that run and forecast where we think a storm will go. So I know there's a lot of research and new grants trying to put more things out there in the ocean to gather that. And that's what the Hurricane Hunter aircraft do as well. So things that affect the steering patterns of a storm, that's a big one, but also, where the exact high pressure center is over the Atlantic Ocean can make a huge difference, for instance. And let's just say a computer model doesn't pick up, a cold front that's coming through the Great Lakes, and maybe it's 12 hours faster than the computer modelers are thinking. What happens then is it can break down what we call this blocking high pressure and allow for a storm maybe to recurve earlier than what everybody thought, or vice versa. Maybe that cold front or, trough, as we call it in meteorological terms, is weaker than the computer models think. And that blocking high pressure over the Atlantic will, as a result, be stronger. That will tend to keep the storms moving further west and not recurve out to sea. So those are just a couple of things that we always watch, and it tends to be a big issue, especially, with those cold fronts coming through. I always, watch, and I'm like, well, I'm going to watch because that looks like it's slowing down. And if that slows down, the Bermuda high is going to be stronger and keep this on a further west track. And that was like the perfect example with Irma, right? It kept on shifting further west. And I saw it doing that. And we updated our forecast for our big telecommunications company clients. Another thing is atmospheric dust, right? Sahara dust layer coming off the African coast. So that tends to inhibit tropical development. So if there's a lot of dust being picked up by satellite imagery, that would tend to suppress hurricane formation and tropical storm formation. If the models don't pick up on that and they don't forecast where it's going to be in 5 days, that could have a big implication on how a storm strengthens or where it's going to go. So those are just a couple of examples of why it's so difficult to forecast hurricanes sometimes, and really why people need to err on the side of caution. If you're in that cone, you really, really need to pay attention. And if you're in an evacuation area, you know what? Heed those warnings, evacuate, go to a safe place, because once you are convinced that storm surge is going to hit, it's going to be too late in a lot of situations.
Very true. It's fascinating to me how many different types of, factors within the atmosphere, even things halfway around the world, can affect what happens here in the U.S. It surprises me every time. And I think, oh, yeah, I should be watching that. And, sure enough, in a couple of days, it can really be have a major impact. So do you think that technology is going to continue to make it easier to track or predict where storms will go, or will there always kind of be a certain element of surprise, even with more data and more technology, those sorts of things?
I don't think we're ever going to be smarter than Mother Nature. There's a lot of research going on, a lot of money going into modeling and forecasting, computer models and AI and machine learning. I think we'll get better, and I think it will get better. I don't think it's ever going to be perfect or nearly perfect. We like to say a 3 or 4 day forecast just in general is usually a good forecast just for the weather. But once you get out to like 6 or 7 days, or, there's a company that I think has a 45-day forecast has a public, very, very, very well-known forecasting company. And that's a joke. That's just based on climatology and models, and if they get it right, they're lucky. But, 3, 4, 5 day forecast, we should start to get better improvements, especially as more money goes into research and we get more of these sensors, which go into computer models and more high resolution computer models. And the big thing, like you mentioned earlier, AI and machine learning, going back and looking at, okay, it's hot and humid out here today. What happened with the same exact situation in the past, however many times? And then the computer model can look at that in half an hour and then give us some scenarios about what most likely will occur. That should get better as AI continues to improve and we get a better understanding on that type of thing. So it's really fascinating. And I think that's where the industry is going. But to your point, I don't think it's ever going to be perfect.
Okay. I didn't think so, but then I know, what do I know?
I can't say it will be, or else I might be out of a job one day, right?
No, I don't think AI will ever be smarter than you are with all of this.
Oh, well, thank you. That's a nice testament. The check's in the mail, Patty. Thank you.
So we could probably talk about weather and its implications for hours, but is there anything that I haven't asked you that you think is really important for our listeners to know about weather or tracking storms or preparing for worst case scenarios?
I think, it's real, like I mentioned a few minutes ago, it's really important to pay attention to that National Hurricane Center cone of uncertainty. And there's a lot of web pages out there, a lot of information out there. there's a lot of armchair weather forecasters out there. And I guess, that just popped into my mind. For everyone listening, Joe Blow, Mid-Atlantic weatherman, has his Facebook page or whatever it might be, or Twitter, and they're making their own forecasts. A lot of those people have no experience or background education in meteorology. So I strongly advise people to just, trust your sources. Trust NOAA, trust reliable meteorologists, people that don't sensationalize everything, people that don't, put up a picture of a 15-day computer model showing a hurricane hitting Miami, because it's likely to change, and the general public doesn't know that. So they get very scared, and these people are just doing it for clicks, doing it for notoriety and maybe money if that's their full-time business. So, insurance carriers, I think, really need to, invest in, a good meteorologist or a meteorology company that specializes in forecasting and knows what they're doing. I mean, we do that, Patty. We have arguably the largest telecommunications company in the world as our client, and we do hurricane forecasting and storm surge forecasting for them for the whole United States and the Caribbean and Hawaii and the West Coast. And we've never gotten it wrong, right? All of their assets have been protected. They have prepared like we told them to. Storm surge never affected their infrastructure. So really, if it's important, or if you're an insurance company and you need to, you want to triage resources appropriately, a lot of people are turning, to private companies like us for triage forecasting. Even private corporations or insurance carriers, they can reach out to people like us, forensic weather consultants or whomever, sign a contract, and they'll get very frequent updates about what the hurricane forecasts look like, what we think is going to occur in the tropics, what we think's not going to occur, and maybe why we disagree with the National Hurricane Center. They're limited to what they can put out in public. We're not. So we'll give a lot of scenarios, and we can educate and inform people to make a decision and prepare properly so they're not caught off guard. So that's really, I think, something that's very important that, your listeners should always consider. No plan A or scenario A, scenario B, and scenario C, so that you can triage your resources, be prepared, and not get caught off guard. Whatever that means for them, I think that's also where where the trend is going. More information from reliable sources helps these people make a reliable decision in terms of where to send adjusters or water trucks and things like that.
Very true. As a journalist, I totally agree about the importance of having reliable sources.
100%. Yes. Yeah. I knew you'd like that.
Well, thank you so much for joining us today, Howard. This was just really fascinating.
No, it's my pleasure. Always a pleasure to, speak with you and see you, Patty, and write articles with you. So, thanks so much for inviting me, and hopefully we can do this again on some other topic. And, maybe at the end of hurricane season, we'll talk about ways for adjusters or insurance carriers or attorneys or whoever to identify what caused the damage to a specific property now that there's potentially going to be 5 different storms in the past couple of years. It's important to know what damage occurred and when. So maybe that's a topic for another time.
Oh, yeah, I will definitely keep that in mind.
Well, thanks for having me, Patty.
Thank you. And thank you for listening to the DIGIN Podcast. I produced this episode with audio production by Anand Khan. A special thanks this week to Howard of Forensic Weather Consultants for joining us. Please rate us, review us, and subscribe to our content at dig-in.com/subscribe. From Digital Insurance, I'm Patti Harman, and thank you for listening.